Yeah. Um, so I'm going to do something kind of like what I did last year, where I just did a bunch of live coding in a playground, except this time I don't even have slides. It's all just going to be live coding. And the topic will be, there we go. Oh. Let's render the markdown. Will be something called lenses in Swift. Well, it's lenses, and then we'll do it in Swift. And the subtitle to that would probably be something like functional getters and setters. Setters which maybe seem inherently mutable, think you're just mutating things. How can you do that in a functional world? And if we have enough time, and we will definitely will not, prisms, which the subtitle of that could be the dual of lenses, which the subtitle would be, I don't know. I'm not sure how I draw this analogy beyond getters. Well, it can be done, but I don't know how to do it that would be as familiar as getters and setters. And we're going to talk about why that seems so not familiar, but lenses seem so familiar. And then more subtext, just keep on getting subtext. It's also about boundaries. When you place boundaries on yourself, how does it force you to do, like, try to work a little bit harder to make something precise and clear and in maybe some sense more correct. There's lots of good talks about boundaries, like Gary Bernhardt, about boundaries. And then, so we'll start. How does one do getters and setters in a fully immutable world? And all right, yeah, I think that's all my markdown. So we're now in the code, and I just want to make sure, is that readable? That's big enough font? Yeah, okay. So so we're going to start with some types that are going to be fully immutable, and these will be the types that we use for the entire talk. And I took these types straight from the Kickstarter. Oh, I work at Kickstarter. Straight from the Kickstarter code base. We got them right here. They're a little bit more complicated in the Kickstarter code base, but they are structs and they are lets. So once you create a value, you are just frozen forever. I'm also gonna do a little bit more. This is the easiest live coding where I just copy and paste. But to make the playground happy, we'll add some of these debug descriptions. All right. So let's create some immutable data from these immutable data types. This might be my last copy paste. This is going to be some values that are inspired by a project that just ended. I don't know if anyone's ever seen Mystery Science Theater 3000, but they did a Kickstarter project that ended 1 a.m. Today. And so I've got some data here from that project. We'll start with this. We have a location, which is Los Angeles. We have a user, Joel, who's the creator of Mystery Science Theater. He is based in LA, and I've got Minneapolis in here because the project was actually based in Minneapolis. So now I've got an MST3K. So now this data, we've got some variables, but they're completely immutable. I can't do anything but read from these. I can get Los Angeles, but I cannot say Los Angeles is LA, and I get a compiler warning. And these are good things. Funnily, I mean, it's a compiler error, but like Xcode is going to help me out to make everything mutable if I wanted to. But we will not do that. So there's one way to do getters and setters, and because getters and setters are so familiar and accessible to us, we might just go straight into it and say we can extend the user type we had, and we'll add the getter. We'll call it get name. It's just going to be a function that takes nothing because the user is implicitly in here. We'll just return that name. And then the setter, this is where we run into trouble, because what do we do if we don't have mutation? How can we set the name? And typically, you might if you had mutation, this function would return nothing. And a function that returns nothing can only do side effects. It can't do anything pure. So we're going to make our setter actually return something. And it's going to return a whole new user in which we just construct a new user, but we stick in the new name for the name, and then we use the current location. So we're just focusing in on one field, switching it out, and returning a whole new user. So now I get to do things like I can take Joel, I can get his name still, but I can also set his name to his full name, Joel Hodgson. And I now get a new user with his full name, Joel Hodgson, without having ever changed the original. All right. So, all right, we're making some kind of progress. All right. So I'm going to do another getter, and this time I'm going to go to the project. I'm going to implement a getter for the creator. So this is the boring kind of live coding where I could have copied and pasted this. But it's good practice. So the setter is going to return a whole new project. And what we do is we focus in on the one field that's going to change. So for name, we get to use the name we already have. For creator, we swap in the new one. And for location, we use the location we already have. And now we get to take MST3K and we can set the creator to be, well, if we use Joel, we haven't really changed anything because the creator of MST3K is the Joel variable. But we could then set the name to Joel Hodgson. And now, and now let's see if I maybe need to bring this over. Yeah, so Joel Hodgson is there in the project. All right, how do we go deeper? We're only going really one level deep. Let's get out. What if I didn't have this Joel variable and I want to say whatever creator MST3K contained, I want to focus in on that creator and then focus in on the name, change it, and then come back out and get a whole new project. So I take the MST3K and I want to set the creator. All right, but what creator am I setting? I don't have Joel right now. I got to go to MST3K and I got to get the creator. And then I got to set the name on that creator to Joel Hodgson. Did I use enough parentheses? Yeah. So now it just keeps, it's only going to get worse from here. If I now needed to focus on from, say, like a project's creators, other projects, and then their locations, it's only going to continue getting worse and worse. So at this point, we could step back and see if maybe if we look to types, we might find something nicer. And we will find something very nice. I'm going to have to put this in comments because it's only going to be pseudocode. But the shapes that we're grappling around with here, we've got something that's like a getter, and it would take a type and return a type. But if I kind of spell this out, what it really is it takes a whole piece and it returns a part. And these could be generic things. A getter focuses in on a subpart. A setter takes a part and a whole and returns a new whole in which the subpart was replaced with that other part. So these are the shapes that are being dealt with. Why don't we give them a first class type? And that type is an amazingly named concept. It's just really great name. It's lens. And all this stuff I'm saying, focusing and everything, it's lens, and just lends itself very well to describing these things. So a lens from A to B, well, B is the subpart, and I could use whole and part, but that would just make this way more verbal. It's going to be a struct that has the getter, which takes the whole, returns the part, and it has the setter, which takes the part and a whole and returns a new whole that has that subpart changed. So now we have a first class concept. Let's create a lens. We could create a name lens for the user that we had previously done getters and setters. Let's see what Swift tells us what happens. It's a lens from user to string because it takes a user and returns the string name. And we see here we need to implement the get and set. So we can do that. So the get is going to have a closure, the set's going to have a closure, and then we'll be done if we can fill in these holes. So in the get, that's the easiest one. I can just say, given the user, just return the username. I can even shorten that more with the $0. I hope that goes away if I implement set. The set takes the subpart name and takes a user and returns a whole new. Oh, I'm about to Java. Returns a whole new user in which we sub in that name but leave the location fixed. So these getters and setters are looking exactly like what they looked like before, but now they're just packaged up abstractly away from the user, just in these closures. And the way one uses it is you could say, well, I'm going to take my lens and I'm going to get from the user, Joel. I get his name. I can also say, use the name lens to set his full name on Joel. And then I get a whole new user, all right? Still, we haven't gotten to anything that actually looks any better than it looked before. I'm going to do the same for the creator, but this time I will copy and paste because I do see this is taking some time. So here I've got a creator lens. It does the exact same thing as before. It's a lens from project to user, and the getter takes a project, returns the creator. It takes a creator and project and focuses in and replaces the creator. All right. So now let's try to use it. Let's try to repeat what we did. Repeat this grossness here and with lenses and see what happens. So we'll take the creator lens on the project and we're going to do a set like we did before. What is it going to set on? Well, we got to get the creator in order to then set the name inside the creator. So we take the name lens and we do a set on it. All right. And what's the set we're doing? We're setting his full name. But on what object the creator lens get of MST3K. And then what was it that we were setting on originally up here? It was MST3K. All right, it did work, but it only looks worse. It only looks worse. We have still yet not done anything good. However, what have we done that is good? Let's see. We've got a creator lens from project to user. We've got a name lens, a lens from user to string. When you see types match up like that, it always means compose. Project to user, user to string. User matches up, that means compose. Anytime you see functions whose return value is some other input value, that is compose, always. So we should promote this idea. We wouldn't have even been able to see this concept in the old getters and setters. Only now can we actually see it. So we're going to define a compose. And on the left-hand side, it'll take a lens from A to B. On the right-hand side, it'll take a lens from B to C. A, B, C get to be anything they want, and it'll return a lens from A to C. And I need some generics in it. It's generic over 3 types. All right, so now I have to implement this thing. I'm definitely going to mess it up, but here we go. So we're going to return a lens from A to C, and now the compiler gets to tell us everything we need to fulfill. We need a getter from A to C and a setter from CA to A. All right, this one is easy. We've got something in A. How do we get something in C? Well, the left-hand side lens has a getter that takes things in A and returns things in B. And the right-hand side lens has a getter that takes things in B and returns things in C. This is really just function composition on the getters. And now the compiler should be satisfied with the getter. The setter is essentially this shape right here, but now made generic for just generic left side and right side lenses. And I'm definitely not going to get it right, but let's just do it. In fact, well, there really is nothing to get right. I'm actually just going to, in my mind, say, oh, the crater lens is the thing on the right side and the name lens is the thing on the left side. I'm just going to type it straight out. So I've got a right-hand side thing doing a set. I've got a left-hand side thing doing a set. I've got the new value, the new subpart. The subpart is C. Then I've got a right-hand side thing doing a get on what the whole, MST3K is the whole, and that's the A. And then finally applying that onto the whole. Nope, I don't think we got it. Is it maybe my parentheses here? No. Anyone see it? No, this felt right here. Oh, it's a left. I'm sorry. This is. Oh, my left-hand side and right-hand side is swapped. The name lens is the left-hand side. The crater lens is the right-hand side. No, wait. I just said that again. Yeah, you know, this is the risk of doing this. If I just had slides, I could have pretended that this was very easy. No, okay, thank you. But all right, just the fact that syntax how that happened. All right. Yeah. So what does that mean though? We can now create a new lens, which would be the creator name lens. And that's just going to be the composition of doing first using the creator lens and then using the name lens. And now we have a lens. Oh, wait. Oh, yeah. Oh, this is Swift one's named argument. So I'm going to slip in an underscore here. Now we have a lens from project to string. We never had that before. Let's feed something into it. Let's do the creator name lens. All right, get back on track. And use it on the MST3K. And now it zooms in to Joel. That's pretty good. So we're getting better. We're not all the way there yet. Now I'm going to take it another step. I'm going to define an operator, an infix operator use. I don't know how you feel about infix operators. I think since we're all functional programmers, we maybe like them, or maybe some people really hate them. But I'm going to use it. And it is just going to just call compose. And now what happens is you get to at a very high level, start composing these lenses together and calling them on values. And even better, I can use that same lens to set the name, his full name. All right, so now this looks good, or at least I think it looks good. So now I'm going to copy and paste. Well, no, I won't copy and paste. We'll do this live. I'm going to show where these things should actually live, because we just keep on creating these lenses and applying them. Where would be like a good place for this to actually live? I think it maybe makes sense for them to be static variables on location. So, or on the value that is getting the lens. So for location, which we haven't even done a lens for yet, I'm going to create a static let name lens, and it's going to be the lens from location into the string, which represents the name, the name of the location. And I can implement this quite quickly. I think I can just do this. And, hilariously, I cannot use $0 on this because I won't be using $1, and then the compiler doesn't like that. So I need to do oh, right. I learned that recently. I won't introduce anything new like that. So, all right, so now we have a location lens, and it's kind of namespace to the type it lives in. So we don't need like a location name lens. We can have location dot name lens. And I have also made lenses for all the other fields, and this I will copy and paste. And most likely, you know, I'm not even advocating for people to be using lenses. We're only using this as a boundary to see where we can take things. But this could also be code generated. Like there could be a script that generates these things automatically, and that's how, for example, some Haskell libraries deal with it. So now we can use lenses to hyper focus on things. We can take the creator lens, then focus on the location of the user, and then we can focus. I'm just trying to find my cursor because then we can focus on the name of that location, and then finally on that composite lens we can set. So this would be MSTK's creator, which is Joel. Joel's location, which was Los Angeles. I'll just set it to LA and put in MST3K. And now I've focused in 3 levels, and I just copy and paste this. You'll see we got Joel in LA. MSTK is still in Minneapolis because we focused in on the creator's location. All right, and that would have looked like truly a nightmare if we were using the old getters and setters. All right, so we're getting somewhere. But now we're going to introduce some weird stuff, more operators. And now you may start to hate operators at this point. So these operators are coming from what some lens libraries do in Haskell, and it's this funky thing here. Anything with a tilde is like a setter, and then anything with, I think, a caret is like a getter. It doesn't even matter. But it is it's left associative, and we're going to give it lower precedence than the composition. Did I spell that stuff right? Associative. Yeah. Should have copied and pasted this. Oh, there we go. Okay. So this is just going to be an infix version of the setter. And on the left-hand side, it takes a lens. And on the right-hand side, it takes the subpart. And then you get a function back, which takes a hole to a hole. I'll just fill this in. All right, so what that means now is we could take the name lens, and we could use this operator on it with the name, the subpart of Joel's first name. What do we get from this? Well, we haven't even put in a user, so all it could possibly do is be a function from user to user. And what would that function do? It would, of course, change Joel's name to his full name. So how do we get it in there? Well, we could do this. But now we're getting back to that weird kind of, it's just not looking very good. So I'm just gonna introduce another operator. That's kind of the way. And all right, and this operator is gonna be this like pipeline kind of operator. And it will also be left associative with a precedence of even lower. Doesn't really matter, something lower than 100. And there will be one which takes a value in A and a function from A to B and just give you something in B. I mean, there's only one definition of this. There's only one thing you can do, and that's just feed X into F. And there'll be another one which does the same, but for functions, where you have a function from A to B and a function from B to C, and you get a function from A to C. Kind of looking like what we did in our lenses. And I'll just do the super short implementation of this. This all works. Okay. So now what does this give us? Well, now we could have taken our Joel and piped him through the user.name lens with the set operator on Joel Hodgson. All right. But we could also take the location lens, compose that with the name lens on location, and we could set any project's location name to LA. But now, and that's now a function from project to project, pipe that project to project function and going down into the creator lens and taking the user name lens and change that to Joel Hodgson. Now we still have a function from project to project. Now pipe that function into taking the creator lens, taking the user's location lens, taking the location name lens, and applying the setter on that to, let's move Joel to New York. And now we have a function from project to project. And what does it do? It sets the project's location to LA, it sets the project's creator's name to Joel Hodgson, and it sets the creator's location's name to New York. How do we know that? We can just pipe MST3K into it. See what happens. And let's bring that out. So Joel's in New York, and MST3K is in LA, and Joel has his full name. So without this, we were just building up an abstract like schema, basically, of how to change immutable values. And then we could just pipe values into it and get all those changes. And in fact, if you've ever seen some of the maybe what you have found to be strange JSON parsing libraries, such as Argo and things like that, this is essentially what is going on. They use prisms also because, and I'll talk about prisms for a very brief moment in a second, but you're creating a schema of lenses and then piping stuff through it. Kind of fascinating. So yeah, I'm probably a little over time, so I'm just going to end with maybe just some remarks about prisms. So what would prisms be? The only way to describe, or the one sentence description is simply they're the dual to lenses. And just like lenses help you focus on, like you have a value that holds many fields all at once and you want to focus on one subpart, a prism takes the dual of, what's the dual of a struct? It's an enum. You don't have all the values all at once. Rather, you have one value of many different types of values, right? An optional is either nil or it's some value. A result type is either a value or an error. And a prism allows you to travel those branches as if without doing a switch. It's like a functional switch. Okay. Yeah. It's like you get to kind of catapult switches into this composability world. And dual is actually a very precise mathematical concept coming from, all of math and category theory and things like that. And in category theory, you develop these concepts with objects and arrows and morphisms. And once you develop a concept, you get a new concept for free, and it's the dual. And you simply reverse arrows. It sounds really simple, and it actually is very simple. But any concept you've ever learned, there's a dual. For example, if you ever did like linear algebra, you learned about vectors and vector spaces. Well, there's also covectors. That is the dual to a vector. There's limits and colimits. Everyone here probably knows what a monad is, but who knows what a comonad is? Of course, Colin. And 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 the really frustrating thing though, all this is beautiful, but what it means is you do all this work to understand some very beautiful abstract concept, and then there's a naturally derived dual version of it that is so unfamiliar and so exotic that it's very hard to grasp. The reason why I couldn't come up with it's the functional blank is because it's not at hand. Just like structs are easy for us, enums maybe takes a moment. And it's very fascinating, and that's why I didn't get to Prism. This is supposed to be a lightning talk, and I think I went a little over. So I'll end here.
Hence, cool beans. If I decided instead of operators to use methods on those lenses over there, would I run into any trouble?
No, only the cognitive load of a different type of cognitive load, because this already has one version of it. But you would not run into trouble. You would just get a lot of parentheses and a lot of words that maybe shouldn't be there. But yeah, by words I mean dot set, dot set, dot set, dot get, everything like that. But
yeah, what I mean is, would it be possible to kind of not have a lot of parentheses after each other, but build a single pipeline out of this, I guess?
So, I mean, you could certainly have created this pipeline lens and then stored it somewhere as like basically a schema and then just sent stuff through it. I don't know if maybe that I'm not answering this question very well.
But I kind of got it.
Okay.
Hey, thank you for the talk. If one wanted to learn more about this, do you have any recommended resources?
Yeah, there's this really fantastic website called FP Complete, and they have numerous articles on lenses. And I think if you just do lens Haskell, it's one of the first. And there's two in particular. There's like the starter tutorial, which is quite long but very good. And then there's one specifically about why lenses are the natural thing to kind of reach for when you're doing JSON. Because JSON, of course, is a very unpredictable thing, and this is where prisms like really shine. And yeah,
that was pretty good. Thanks.
FP Complete's a very good website.
Yes. So here you created all these lenses manually for the particular structures you were going to access. And I was wondering if Swift has the abstraction powers that are necessary to create those lenses automatically, not having to rely on external code gen. The reason I'm wondering about this is that it reminds me of a couple other things. It reminds me of something like XPath, which is like a mini language just for indexing into a composite structure that consists of arrays or dictionaries. Or enclosures, people talk about key seeks, which is the same idea. You have like an array, but it's a heterogeneous array, and it has either integers, which are indexes into an array, or basically strings or symbols that are keys into a dictionary. And in Cocoa we have NS index path, but that's only good for going into composed arrays. And there's not really a good facility just for indexing into compositions of dictionaries and arrays. And in Swift, I imagine it'd be even harder because everything's so static. But this seems like the kind of thing you would use for it if you wanted to have a general purpose.
You know how in Swift, if you define a method on a struct or a class like that, it also becomes a static method on that class. So if you had, well, in fact, I guess I can do user dot. Yeah, I've got my get name here, even though I'm not calling it on a particular user. It's now a static method. I got that for free. You don't get this with properties. I don't have just a user dot name, and that is kind of where it should maybe live. You just kind of should get for free a static method version of your properties, if such a thing makes sense. And I'm just kind of like only spitballing here, but that's where I think it lives, because I want only to really go one level deep at a time and then have these nice composability properties to play around with. So I kind of want, if I say I've got a let name, let ID, let creator, I just want user dot those fields to just have like the getter and setter for free. That's right. And but to answer like the original Ruby question, I'm almost certain there is no generic way of doing this. You need code generation for the whole thing. Don't we have like GYB GB or GBT, something like that. Now with open source, that's probably a thing. All right, thanks.